everyone. Welcome to AI in Practice with the University of Baltimore. And I am joined today by not only our guest speakers, but I'm also joined by our collaborators who are Johns Hopkins University, as well as UMBC, and then our Center for Entrepreneurship and Innovation. This is our last AI in Practice webinar for the semester. So we are really excited to bring in two guest speakers for you today that have very different perspectives to share with you. So we're really excited for that. I'm going to allow them to introduce themselves, and I'm going to turn it over to Julia to continue. Thanks, everyone.
So welcome, everyone. We have two speakers who are going to kind of take us through the steps of preparing our students for AI-driven research positions. You know, we're seeing this major impact these kinds of tools have on the way that we do research in academia. And so we are going to start off with Zach Kinzler.
Hello, everyone. Thank you for the introduction, Julia. My name is Zach Kinzler. I'm the Senior Solutions Engineer here at Boodlebox. A little background about myself. I have a degree in Industrial and Systems Engineering and a master's in Business Analytics and Data Science. When I was in grad school, I did a bit of research on my own, and I interviewed about 1,000 college students about how they were using AI in the classroom a few weeks after ChatGPT came out. And that's landed me here at Boodlebox, where I'm lucky enough to be talking to people all over the world every day about how they're using AI in research, education, in the workforce, in the government, all different breadths of life. But today I'm here to kind of talk about AI in research, as the theme is. But the big thing that I want to talk about is like how to prepare students to use AI in research, because there's two different things in my personal opinion. It's like using AI for research and empowering students to do better research using AI, which are two different things. Because there's lots of cool tools, which you're going to see in the presentation after mine, that will help you do research. But there's lots of parts of research like writing, things like that, where AI can be very, very effective. And I think those core AI literacy skills are very important to have to even be able to use cooler tools. So a little thing that's very important that I kind of want to touch on that relates directly to Boodlebox as well as research is there's some negativities about using AI, right? Security. When you're doing research, it's very important that the research you're doing is safe with you. And here at Boodlebox, which I'm going to show you in a few minutes, is that everything that you do on this platform is completely safe, private, and secure. Second is collaboration. Working with multiple people on research is very important. Students are often working with a faculty member, or faculty are collaborating with one another. And it's very important to be able to use AI together, as it's very difficult to be using, research tools that are siloed within one person, because you need to be able to collaborate on these things. So one cool part about Boodlebox, which I'm going to show you today, is the collaboration feature. As well as this is literacy, right? To be able to use AI tools, we need to understand what's going on. We need to understand how to use AI to summarize things, find research papers, find articles, things like that. So there's a bunch of stuff that I'm going to show today that really kind of hammers home on that AI literacy. So I will be manning the chat throughout this. So if anyone has any questions, please shoot it in the chat and I will answer it at the end. As we do have a lot of information and I got about 15 minutes before I got to pass it over. So I'm going to jump into Boodlebox. When you come here, you're going to see a normal chat interface. And there's a few things that I really like to touch on before I jump into the platform itself. So first is data security. Like I said, when you're doing research, it's incredibly important that that research you're doing is your own and you're not giving it to large language model providers. So here at Boodlebox, we are FERPA compliant, HIPAA compliant, GDPR compliant, SOC 2 compliant, and that's for educators. So the whole idea of this is that everything you do on here is your own and it's not getting shared outside of this. As well as that, we reduce environmental impact of AI by about 95%, which I can touch on another time. But I want to jump into some of the AI tools we have available. And some of these are directly helpful with research and other things. So these are all just custom GBTs that will straight line you into doing exactly what they say they do, right? So academic writing assistant, research paper analysis, and these are all different based on your experience. So if I come up here and I change my experience to student, these will also change. But these student tools, they do have research things that are custom GBTs that will help you do research. So for the sake of this demonstration, I'm going to start with post-secondary faculty and staff. And I'm going to jump in with Perplexity. This is a great tool for high-level research of scanning the internet. So Perplexity is a search model. So I could tell me about some recent publishing in the Baltimore area around AI in education. And while this is searching, I'm going to walk through the different models that we have available here on Boodlebox. And one thing I want to touch on is that all of these models have their own benefits and their own lacking areas, right? And when we're doing research, it's very important to be able to use everything that's available because they're all good at different things, like I mentioned. So ChatGPT, unlimited access to all of the OpenAI models. 4.0 is great for brainstorming. ChatGPT 5, I like to use for more complex tasks. And Claude is my favorite model for writing, especially when I'm doing writing up research of talking to students and things like this. I use Claude, and I like to use Claude 4.5 Sonnet and 4.1 Opus. And these next two models, Gemini and Llama, when you're doing research, you're handling large amounts of information at times, right? And all AI models have these things called context windows. And what a context window is I like to explain simply the amount of food an AI can fit in its mouth. And these context windows vary per model. So for reference, ChatGPT has a 250,000 to 500,000 token context window. Gemini has a 1 million token context window, and Meta's Llama has a 10 million token context window. So what that means is that Meta Llama can inherently ingest about 10 times more information than Gemini and about 40 times more information than most GBT models. So when you're doing research, if you have large amounts of documents or large amounts of written papers that you have in a chat, using Llama is a very effective tool to kind of break down, synthesize research. And Llama 4 Maverick is the one I like to use. Amazon, totally stay away from this one if you're doing research. This is more of an AI literacy model that we have in here. It's the worst one on the platform. And the reason we keep it in there is so you can kind of see the difference in how these models interact with one another. Mistral, if you're doing any research that involve other cultures outside of the United States, for everyone's understanding, a lot of the GBT models were trained on, United States data and things of that sort. Mistral is a European LLM that was trained on European data. So it kind of offers a different perspective when doing research. And I would recommend using Mistral Large. It's a very interesting one if you're dealing with cultural research because it functions very differently than other models. Web research. These are incredibly important when doing research, hence the name. Perplexity is a model that's specifically designed to search the internet. So what this will allow for you to do is get real-time sources, which I'll show you. And then Semantic Scholar is an incredible research tool. This gives you access, if anyone's ever used Research Rabbit or Elicit, this is the engine that powers those. So Semantic Scholar gives you access to 215 million research papers on a database. And this functions very differently than a normal large language model. It's because it's a search model. What this will do is give you an abstract and a downloadable link to papers. So for students or faculty, if you're looking for published scholarly articles, Semantic Scholar is a great way to cut down time on finding those. And then we have access to all these image generators. This is less important for research, but if you want to make an image of your research, Nano Banano is awesome at creating graphics and things like that with consistent characters and stuff of that sort. So our Boodle bots, so these are stepping away from large language models, moving into custom bots. These are just exactly what they say they do. So research, we have all of these bots that were built by educators that we have in the platform that will help you do these if you're not an expert large language model user. So I like to explain the difference between a large language model and a custom bot, as a large language model is like a zip file of the whole entire internet. When we're doing research, hallucinations are a very, very real thing, right? And you can't be writing research papers with fake references. So that zip file of the internet is always going to find an answer for you. A custom bot is like putting a little box around that zip file that says you can only think, do, and act in these certain ways. So I would highly recommend people checking out these research bots because they're very, very helpful in kind of just synthesizing information, acting as an assistant, acting as a thought partner, rather than just a doing tool. You can build your own custom bots on Boodlebox, which is incredibly valuable for research. There's lots of repeated things that you do in research. And I find myself, if I do something more than 2 times in a day, I will make a custom bot that will automate that for me. And then you are all the experts in your research. So building these custom bots will allow you to create like personalized assistants that can help students synthesize information in certain ways, or always ask them certain questions to help that critical thinking like deepen in the research process. And then this Discover tab is more just meant if you don't know what you're doing to come here and be like research tools. And then it will recommend which bot or models to use. So Perplexity, search the internet. These sources are all live, as well as available here. And as I mentioned, it's very important to have AI literacy. So if you've ever used Perplexity, you'll notice that there's not academic AI skill progressions when you're using Perplexity. So this is the Boodlebox coach mode hard at work. So what this will do is teach you AI literacy while you're using AI. So what I can do then is I could switch to Claude. And when I switch to Claude, this will allow for me to be like, I am working on starting a research project on how AI is being implemented in higher ed. How could I use the successes from above and model my own research project? So what I'm doing here is bot stacking. So Claude can communicate with Perplexity. So all of the models are able to talk to one another within Boodlebox, and there's a few big benefits to that. Like I said at the beginning, they're all good at different things. And because they're all good at different things, you can use them all together, right? You can synthesize things together. So you can use the best of all worlds in one chat, and they all understand one another. Second is hallucinations. And like I said, when doing research, we can't be having faulty articles. We can't be having hallucinations in the research papers. So what you can do with this is stack models on top of each other. And it's actually proven to reduce hallucinations by about 95%. This isn't just a Boodlebox thing. If I were to open Claude, Perplexity, and ChatGPT in all three tabs and copy and paste outputs as inputs, it would do the same thing. Boodlebox just makes it incredibly seamless to do so. So as you can see, it will tell me which models to use, where to start doing research, create a research assistant bot. So these models can all understand the Boodlebox platform as itself. And then again, as you can see, some prompt engineering tips for educators. So this will coach me on using AI for research while I'm using it. So I'm going to just check the chat and see if there's any thing I need to answer.
You just had some curiosities about a list of all of the different explanations you gave. So I linked the resource from the Boodlebox site, their guide to Gen AI models and bots.
And then I also have a video of me doing exactly what I just did. And I'll put my email in the chat. And if you want it, I can send it to whoever's interested. But the thing that's really cool about this is that, yes, it's beneficial for me to chat with all of these different models in a singular chat. But the thing that's really cool is if me and Julia were working on a research paper about how higher ed was changing with AI in Baltimore, I could grab this little link right here and I could send it to her, and me and her could work in a group chat in real time. So I'll kind of just show an example of like what this looks like. So here, this isn't necessarily research focused, but this just kind of highlights exactly how this technology works. So as you can see, there's multiple human beings having a conversation. I like to say I wholeheartedly believe that the human being is not at the center of the human AI interaction the way that we see it. And that's because every time you talk to ChatGPT, anytime you talk to any model, research tool, or anything like that, it's a one-to-one interaction. You talk, it talks. You talk, it talks. And even in some situations, it's more than you talk and ChatGPT goes and does 6 things and then it comes back to you. But here on Boodlebox, what you can do is you can switch to message mode. And when I switch to message mode, what that allows for me to do is provide context to other human beings as well as large language models. So I can be having a conversation and then I can call ChatGPT into the conversation, and ChatGPT allows me to seamlessly understand everything that was going on within the conversation. So it's a very valuable tool for human to human collaboration as well as human AI collaboration. So when you're doing research, I would use our foldering system here. So you can build folders and you can share them like nesting. I like to think of it like a Google Drive. So if I shared a singular chat with you, you would be able to just see, edit, and work in that chat. But if I shared this folder with you, you'd be able to see everything below that. So the research groups that I've worked with, what they're doing is they're creating folders for each project they're working on. And then the students, faculty, staff, anyone who's involved in that research project can all go interact and see what people are working on together and kind of monitor the research. And the other thing that's really cool is that, say, if I had 3 student groups doing research and I wanted to check in on them, what I can do is I can grab this folder and add it to my knowledge bank. And what the knowledge bank is where you can upload documents. So this is incredibly powerful for research. You're going to want to have AI analyze documentation, tell you what's going on, things of that sort. And the other thing that's really important is that the things you upload in here are safe. So everything uploaded in Boodlebox is encrypted. So I can't go see anything you've uploaded. Our engineers can't go see it. Nobody can see the stuff that you're uploading. So this is all completely private, and it also doesn't break copyright if you upload things in here because it's inherently not going outside of the system, and we don't train any models. So I can upload documentation, and I can also stay organized in my knowledge bank. So I can, if I had a research project, I could go upload all of the documentation that I want to research in a folder. And then if I want to bring it into a chat, I just grab this attach from knowledge, pull it in from here, or I can just upload a file directly. And the thing that's cool is I can upload other folders and chats into other folders and chats. I get a little meta when I talk about this. But what this allows for me to do is upload group one's folder and a rubric, and I can go analyze how the students were working. But more importantly, right, like the rubric's a bad example, like using it for grading is cool, but not in any way beneficial. But the big thing that you can use it for is like, okay, this is my goal for my students' research project. Where are they straying away? What are they getting? What are they not understanding? AI is really good at apples and oranges. So it's some way that you can analyze how your students are doing research, past research compared to current research, and just kind of spider web things together. And the last thing I want to cover before I pass it off is building a custom bot, because this is incredibly beneficial for research. So if you've ever built a custom bot, this is literally exactly the same thing as custom GBTs, gems, wherever you've done it before. Whatever you write here instructs the AI on how to think. So this is my silly example to teach the technology. I say answer everything in a joke, and this says tell me about George Washington. It tells me a joke about George Washington. But a better example is here's a tutor, but this tutor can be built into being just about anything for research help. You can put in the definition, like the scope of the research project, all of the documentation that you want the students to follow, and then the bot will reference this every single time. So this is kind of like building your own little research assistant that can help students do research. And it's not to get rid of research assistants, it's to empower them to do more, is what I like to say. So you have instructions, you have a description and a greeting, and then you upload knowledge, and this is what the bot will reference every single time. And the thing that's unique about our bot builder is you can pick which model powers the backend. So if you have a ton of information that this bot's handling, I would use Llama. If you want the bot to search the internet every time, like a citations checker, have it be a Perplexity. So it allows for that further granularity when building bots. And then after I build a bot, if I just grab this and share it, anyone can use it. I know I'm coming up on time, and I kind of want to leave a second or we'll do question and answers at the end. But this is Boodlebox. Since I have 1 minute and we're not doing questions right now, one thing I want to show is I've done a lot of like work with research on people in other countries. So I was just a part of a hackathon that we sponsored that I got to mentor. And what that hackathon was connecting students from Argentina, Rwanda, Slovenia, and Croatia. Because what you can do in a Boodlebox group chat is I don't speak great Zulu, and the student I was working with does not speak great English. So I can be working in English, and my friend Sikle can be working completely in isiZulu, which is his native tongue. So you can seamlessly collaborate on projects with people that don't speak the same language as you. And as you can see, this is me and my friend Sikle. He lives in Johannesburg, South Africa. So the collaboration across cultures is really, really cool and kind of unlocks a lot of research opportunities that wouldn't be there before. So thank you so much. I'm going to pass it over. I don't want to go over my time, and I will slowly get to those questions in the chat.
Awesome. Thank you so much. I do have a quick question. Really quickly, I want to touch on before we move to our next speaker. So what in your experience, Zach, actually, if I could have you hop back on, thank you. Really, one quick question. Is there one thing you could say about your experience working with students on AI in general, you know, whether they are using Boodlebox at their university or they're using other tools at their university? What are the kinds of things that you're hearing from students?
Yeah. So I have a podcast and I probably talked to 3,000 students at this point. And the biggest misconception is that students use AI to cheat. They do, but kids were cheating before AI was a thing. The real thing that I hear every single day is that students are equally scared and equally have no idea what's going on. And they really, really, really want to know. So faculty members, administrators, staff, like these kids want to learn from you. And I know it's uncomfortable to teach something you're like not an expert in, but the number one thing I hear from students is that I have no idea what I'm doing and I'm scared to talk to my teachers about it because I don't want to get in trouble. So that's really the big misconception that I like to kind of talk about is that kids want to learn about this stuff. They don't just want to cheat. But yeah.
Awesome. Thank you so much. And it was great to hear, whatever platforms you're using in your institution, in your university, in your own personal, that there are pros and cons and strengths to each one. So really appreciate that perspective. And now we are going to shift to Dr. Kamal Choudhary.
Hey everyone, good afternoon. It's great to be part of this webinar. Let me try to share my screen here. How does that look? Do you guys see my screen?
Yes.
Okay. So yeah, thanks Mike for inviting me and others organizers. My name is Kamal Choudhary. I'm a professor at Johns Hopkins University with Department of Material Science and Engineering and ECE. Today we're going to discuss about agentic AI for science, especially with atomgpt.org. So this is the outline. We'll discuss why agentic AI. Then we'll discuss what's the need of benchmarking AI. Then we'll talk about a custom GPT called ChatGPT Material Explorer. And then we'll go into an open source version of it at atomgpt.org with demos. So let's start with why agentic AI. Standard AI models are probably not very suitable for scientific tasks. Why? Number one, hallucinations. This is the biggest problem, especially for scientific tasks, where an AI model provide incorrect results with high confidence, or sycophancy, where LLMs are over positive or praising over your responses. Most of these models are black boxes, which is not good for science. Science likes reproducibility and open access policies. They are non-reproducible. That means if you ask the question today, 3 minutes from now, if you ask the same question, the results may not be the same, which is not good for science. Scientific fields such as physics, chemistry, math, biology are super vast. And these models are usually trained on internet data like your New York Times, Wikipedia, and so on. And training on these particular domains is quite tedious. So what is the solution? We have two possible solutions. Either you teach them or you train them. How do you teach them? You teach them by connecting them with scientific database and resources, a process called tool calling, model context protocol, and so on. I'll not go in details of what these things are, but you are basically exposing several tools or several resources to the model so that you can figure out which one to talk to. Or you can train them by developing a specialized data set and then fine-tuning some of the layers of the neural network for that data, and that's for training. Sometimes you can use both of them, and that's some of the ways to improve hallucination in these large language model or AI model. There's a really nice article by Google and OpenAI, Startup Technical Guide AI Agents, and OpenAI is a practical guide to building agents. In this, you'll get a much more detailed and quite layman perspective of how does this agents work and how to actually get it started with this. So I would recommend if you want to look into agentic AI frameworks. Before I go into the agentic AI, I wanted to bring out how these LLMs work. It's quite important, in my opinion, to understand at basic level, how does this actually work. It's based on a foundational paper called Attention is All You Need. This paper has been cited over 200,000 times in just a few years, which is phenomenal. And the idea is, suppose you ask the question, hi, how are you? And the response you get is, I'm fine. What happens underneath is, suppose if you have a dictionary and you find where does the word hi, how, are you, question mark occur in that dictionary, and you give the index of that word in the dictionary as the input vector. And similarly, I am fine, you find the dictionary index, and that's the output numbers. Remember, computers do not know physics, chemistry, language. They only know numbers. And that's one way to convert this information into numbers. Now we have this x vectors and y vectors in input integers as an index. Now you can establish the relationship between them for entire literature like Wikipedia and so on. And that's how underneath how it works. So now once you have trained the model, now you ask the question why the sky is blue. Now it will predict you the next token, and that's how these LMs usually work. Now, this is generative AI, what I just showed you, which produces content, text, image, data, pattern-based responses, and so on. What is agentic AI is a bit different. You can consider this a brain, and this brain plus hands, where it actually takes action on your behalf, solves problems using tools and planning, calls API, application programming interfaces, databases, and runs calculations. Again, I would recommend you to take a look on this document here. Let me start with a very simple example. How's the weather in Baltimore? Or how's the weather in New York City? If you ask this question to a static model which was trained up to a certain date data, then it won't be able to get the question right. Okay. Suppose I ask this and it's running on the atomgpt.org. You can see this says, I don't have access to the I don't have real-time access to the current weather. Now I take the same prompt, put it there, and then I turn on the web search, the blue icon there. Now it has access to the outside external resources. It can look it up, summarize the details, and then provide with the answer. And that's one way to remove or at least decrease the hallucination in their output. And there are many other tools and API calls are integrated in the atomgpt.org. There are 2 million plus models on a resource called Hugging Face. Hugging Face is a common platform for hosting your AI models. You can see there are 2 million models. Which one should I use? And that's raises an important question. And that's why we'll talk about something called benchmarking. Why do we need benchmarking? If you look into the literature, up to 1900, 2000 and 2010, it used to be about big data and multimodal data and so on. Today, you'll see mostly discussion around design benchmark. For example, ChatGPT beat a medical exam students. ChatGPT beat a lawyer and so on. So these are also a sort of benchmark which these models can easily nowadays break. And it's getting harder and harder to find problems where it does not work, honestly. Let me start with a very simple example of benchmarking. If you go to the atomgpt.org, you can select more than 8 or 9 models. So if I go to the AtomGPT, select GPT OSS model, I'm selecting Llama model and Gemma model. So these are from OpenAI, Facebook / Meta and Google. Now, if I search this, you can compare all of them into one chat platform. And you can see even for the simple question, this model gives you 3, 2, and 3. This is a very well-known hallucination problem or hallucination benchmark for large language model. So the way these models are designed, it sometimes very hard to answer this kind of question. Again, big disclaimer, this is not judging the overall platform or their architecture, but just few examples how to do a simple benchmarking test. Now, we don't need just benchmarking, we need reproducible benchmarking, right? So for example, if you read a letter from Stanford University, ChatGPT, ArtScore, medical students, can I actually reproduce this results by myself before I trust these results? So this is the reason why there are several leaderboards like UGI's leaderboard. This is from our group called Jarvis leaderboard for AI, many other domain sciences for reproducible benchmarking of the facts, not just taking anything, but actually checking it before you accept it. And there's one way, in my opinion, for next generation of students to teach them in a future way is ask them to reproduce benchmark. So reproduce benchmark with this paper, with data set, and you document all the steps. In this way, you learn how this was done, and then also learn how to go to the next step. Now let me talk about a bit more details and some of our recent work called ChatGPT Material Explorer. If you ask ChatGPT, what are the chemicals with aluminum oxide, for example, it might make up some numbers. So if you can link with this database, like Jarvis DFT is a chemical database, if you link with it, now it can give you a much more reasonable and accurate answer, and not just give you answer, but actually analyze the results. And this was published in the Nature IMI journal, ChatGPT Material Explorer, one of the first custom GPT from material science. It made a lot of news. So it was published in the Johns Hopkins Hub article. Several people made YouTube videos on it. Feel free to check it out. So these ChatGPT Material Explorer, although it's built on ChatGPT, it's working under ChatGPT with under the hood model ChatGPT 5, but we don't have access to the ChatGPT 5. This is why that led us to build an open source analog or open source version of ChatGPT Material Explorer on atomgpt.org. If you go to the website, you can log in with either with your Gmail, with your GitHub, or simply with your email. There are several YouTube demos available, and this is totally free, totally for anyone to use. There are at least 8 open source LLMs hosted there. This can search materials databases, property prediction, experimental analysis, protein structure analysis, literature search. Your data is not stored, unlike other models like ChatGPT and Claude, where those data are continuously being fed to improve the model. This is not the case for atomgpt.org. Also, you can have custom function calling a tool, a model context protocol. Currently, we launched this about 2 months ago, and we already have over 2,000 users. And there's also an API description at atomgplabs/AGAPI GitHub page. Let me show you an example how to search a material in AtomGPT. Suppose you want to find all the materials in gallium and arsenic in a particular database. It will talk to the database, organize the data for you, and then give you the results. This is based on an infrastructure that we previously developed called Jarvis. Infrastructure is all you need for material design, and this Nature article on Jarvis for data-driven material design. Now we're integrating this in the atomgpt.org. I want to point out there are numerous combinations of materials out there. Let me talk more about this. If you look at this periodic table, for instance, there are 100 elements. Even if you take 10 atoms at one time, the total number of combinations can be up to 10 to the power 100 or more, even if you take different arrangement of atoms. This is why I think common large language model will probably never be able to solve this gigantic task, because the data is so huge. It's not just internet data. This is why we need to integrate physics-based model in the ChatGPT or some sort of AI model like this. One of the model that we developed in our group a few years ago in Nature, atomistic line graph neural network, it can take, for example, any combination of atomic structure, atomic elements, and then combine them and predict properties like formation energy, such as whether if you take few atoms, whether it will form or not, whether it will be able to conduct electricity or not, whether it will be hard enough or not, So these kind of things, if you want to predict this using ChatGPT, it will not be very reliable. It will hallucinate. And this is why having models such as this kind of Align and several other models inside AtomGPT will give you reliable results. So here I'm giving you an example of how to predict properties of this crystallographic atomic structure. So this is a way to, POSCAR is a way to generate or represent atomic structure. Now, if I give this prompt and give a atomic structure file and press send, what happens? It takes the data, feeds to the graph neural network model, synthesize it, analyzes, and then gives you the responses, whether the material, in this case, I think it was silicon carbide, whether it will, so you see it's processing uploaded file, prediction completed. Now it will give you formation energy, band gap, shear modulus, whether it's a superconductor material or not, and so on. Another idea is it can conduct electricity or not, but I want to know how effective it is. And that's why we need something called electronic band structure. So it's a way to solve quantum mechanical equation, Schrodinger equation. Now you can solve this in a chatbot. So you can predict the electronic band structure, which requires sophisticated quantum mechanical description now in a chatbot. So this is some of the powerful things we can do with this infrastructure. Not just theory, you can also analyze experiment with this. So X-ray diffraction is suppose you take a material and shoot it with light on X-rays. The pattern you get is a unique signature of that material. And that's commonly used in physics, chemistry, math, biology, and material science. And now if you ask ChatGPT, this is my X-ray diffraction file. Can you predict me the crystal structure or atomic structure. Of course, it won't be able to do this. So this is why we developed this Diffract GPT. It's a diffraction-based GPT platform and integrated that in atomgpt.org. Now what happens, it generates the atomic structure based on this customized X-ray diffraction specialist. And this is what makes it a more reliable resource for scientific tasks. Again, if you want to write emails, check some grammar, feel free to go to use other tools. But if you want looking for scientific tasks, then this is the way to go. And you can see that it has generated atomic structure, which is what element it is, what is the coordinates, x, y, z coordinates, what is the lattice parameter, and so on. You can also use microscopy with this. So if you take a microscope image of some material, upload to it, and this is still a work in progress, it will generate the atomic structure. So you can link this atomgpt.org with your experiments, with like X-ray diffraction, microscopy, and other tools which we are building, and then it will remove or at least decrease the hallucination with this. Another thing we talked about is the literature search. If you at least nowadays the models have gone really better. They actually do this agentic framework inside it. So, but few years ago when we started, models like ChatGPT used to make up all kind of papers. So what we did is, if you search, for example, find me papers on magnesium boride and show me top 10 results, recent papers. Now it will talk to a platform called Archive or Crossref or Google Scholar, and now it will give you much more reliable results compared to models like other models. Of course, again, they are getting better as well. They are actually implementing these kind of resources in an agentic framework, and this will be more reliable results. So we can use commercial chatbots. You can use open source chatbots. Good thing about open source is you can get a variety of it. You don't have to be tied to either of these models. These are much more reproducible. They have API version. There is no time limit, and it's based on open source model, as I said. We recently organized a hackathon called Agentic AI for Science Hackathon. It was about 120 people. You can find more details about this at this AtomGPT Labs/AAI for Science GitHub page. And what we provided is a Google Colab notebook where you can sign up in atomgpt.org, get your API key. It's kind of a way to interact the atomgpt.org with your personal version on a code on a Jupyter notebook. And then what we did is we asked the student to solve problem in an hour. So if you want to not just listen to empty talks and want to learn it by doing, what I would recommend is go to this notebook and see whether you can solve this problem in 1 hour. And if you can do that, even if whatever you can do that, you can save this GitHub on GitHub, this GitHub gist as a Google Colab, and then share this on the Google form that is provided in this hackathon. And then we announce that who will be able to solve fast will be the winner. At least for the hackathon, they will be the winner. But it's a good way to at least to learn, familiarize with OpenAI compliant API skills for that atomgpt.org. Ask all kind of questions, develop all kind of specific tools. So with that, I'd like to thank you for your attention and time. Thanks, Mike, again for the invitation. I'll encourage you to check out atomgpt.org, sign up. If you missed my some of the other tags, if you are interested to listen to my mother tag, I have a YouTube channel, about 500 subscribers, and this is my link to the YouTube videos. So with that, I'd like to thank you for your time, and happy to answer any question if you have.
Dr. Choudhary, thank you so much. I do have a quick question before we shift into our Q&A. Just wanted to kind of tie some things together here. I'm really curious, these are really incredible examples of the next level of AI use. And kind of going back into the experience with faculty, where we have faculty who aren't sure where to start, but we also have students who are feeling that, question of where do I begin? Maybe there's some hesitance there. What has been your experience to helping build that confidence from that reluctance or that hesitance into going into this deeper level of research?
See, research has been always, in my opinion, research has always been a policy where we first find where things do not work and try to improve it with advancement in science. This policy has not changed, in my opinion, whether it's AI, non-AI, 100 years ago, right? For example, when I was working with ChatGPT, I found it does not work for material science. It gave me the opportunity, tremendous opportunity, to do a research on that field. And this is exactly what I teach my students, that you should have a very foundational challenge where this model did not work, and try to improve it with your domain knowledge, and then use as a digital twin or use as a partner to solve the problem. So to see this as a solving problem, other than this is better than that, and a human is better than AI, or AI better than humans. We should not compare this. We should focus on solving real life problems. That's really the focus. If you have that in mind, then things will be much easier. You benchmark and then you solve the problems.
Thank you so much. I see Mike's hand up. I am going to invite Zach to turn his camera back on, and also encourage, I know Zach has been responding to questions that are put in the chat and the Q&A. We have the rest of this time to answer all of your questions, whether they are to a particular speaker or to both of our speakers, a little bit more general. Please throw them in there. I'll be keeping my eye on the chat and the Q&A as well, but I will pass it over to Mike.
Thanks, Julia. And I also want to thank Kamal and Zach for presenting today. And one of our goals here is that many of us are teachers. And so we're trying to learn how AI is shaping the work in different domains. And today it's about science. So to make that a little more explicit, I'm curious, and maybe we can start with Kamal. It's really interesting how the tools you've built that are agentic as opposed to generative are improving the work you're doing. Can you help me understand more clearly? So the tools that you're providing, how do they replace work that you traditionally do or enhance it? So for example, like I know with protein folding, AlphaFold is an application that is using AI to predict proteins and the way they fold, and is operating differently than old tools. Is that what you're doing? Are you replacing work that you would do in the lab? Or are you using these tools to make predictions about what materials to investigate in the future using your traditional methods? So you can talk a little bit about how the science of the work that you do is changing based on those tools. And Zach, I invite you to do the same with the BoodleBox custom GPTs.
Yeah, I can go with first. So there are two ways we are doing this, right? Either you can take the domain AI models like protein folding and so on, and then try to improve it based on the current benchmark of it, or make it easier for people to use. So adding them into a chatbot, you can have fantastic model, your Nature or Science paper, but if people cannot use it, that's a challenge. So we're trying to solve both of these problems, improving the models, as well as improving, as the model improve, we are integrated in the toolbot. And for all my PhD students that I have in my group, their project, they won't get their PhD unless they have developed a tool like this and integrated in atomgp.org. Basic minimum criteria. That's some way to do a meaningful research in the era of AI, in my opinion.
Great, thank you. And Zach, I invite you, if you want to talk a little bit about how the research process users, one of the questions I wrote down earlier is you have a number of those custom GPTs. Do you have user data about which of those custom GPTs people are using to give you a sense of where are users taking advantage of your tools to improve the research process?
So we don't actually see that data on purpose, kind of because of the data security stuff that we do. We stay very hands off from everything that's going on. But from the conversations I've had, a lot of it is just those the thought partner things. I have a bunch of research professors that are building things that'll ask students questions did you think about this? Check this. Did you research checkers, right? So here's a source, let's go figure out where that came from. Where did you find it? So it's more it's very use case general, but inherently the way that they're doing it is just that every single time, a repeatable process or a thought partner is the biggest way, really, I've seen in research, where it's helping them think of other ways, other things, asking the students questions. And then a lot of it too is just analyzing large amounts of documents repeatably, right? So it's this is my research. Help me find out of this paper what relates to my research. That's probably the biggest use case. So they put everything that they're researching in a custom bot. And then whenever they find a source, they just give it to that and they don't even have to say anything. It's like, okay, what from here matches what I'm doing? And then it helps them through it. But lots of different ways.
Great, thank you for sharing. And Julia, I see there's some questions coming in, so I'm curious what other questions people have.
Yeah, I want to touch on one that I think both Dr. Choudhary and Zach would be able to speak to, that if you could present any cases that they can think of where the use of AI in higher ed or research is counterproductive or not useful, kind of thinking, where does it not have a place?
I mean, I can answer this. Like it it doesn't have a place in a lot of places, is what I like to say. So I have a master's degree in data science and business analytics, and like a lot of the basic coding, like you probably hear tons of times like coding's going away. Like coding is not going away in my opinion. Like I can code so much better than people that have no idea how to code with AI. And I think where it like doesn't need to be in certain places is those like foundational skills, right? But then foundational skills are changing. Like in certain places, certain foundational skills aren't necessary. But you can't discern an AI if you have no idea what you're talking about. And you need to know like what you're talking about. So I think in those foundational skills, like I believe in some writing classes there should be AI and some that shouldn't be, right? And the ones that shouldn't be, it should be more about like what does good writing look like? What's the goal of this paper? And then certain classes should be more about, okay, we have to make a really good paper. I don't care how you get there, right? So it's like that foundational skills and the baseline knowledge of subjects. If you want to be an expert in, you have to learn the basics. And I think that varies across industry, but I'll pass it over to the
Yeah,
Kamal.
we can add something more to this. The way I see AI as making you 10x of whatever you are. So it's good in accelerating stuff which is repetitive, okay? Writing emails, writing this and that. But if you're trying to do something innovative, new, just for my field, finding a new superconductor material is very, very difficult because there are not much data out there. So if there is no repetitive things, this is the opportunity for individual researcher to hone on it, and make it repetitive, and then move on to something different type which is not repetitive, make it repetitive, and keep building like this, in my opinion.
Thank you. Really appreciate that. I'm seeing a few questions that I'm going to try to, fuse together. And it's kind of the, concerns from a faculty use point, trying to develop things that work well for their students. So thinking about trying to make something discipline specific, or trying to make sure that it's not making mistakes, grounding it in a really good way, but also seeing that faculty concern about, is this making my students lazier? Is this taking away from some of the grueling tasks that we know that students build in higher education? So I guess I would just say, if you were to give recommendations for faculty to implement AI into their classes, what are some of the top things that they should be keeping in mind to navigate some of those fears and concerns?
I mean, I can go really quick. The thing that I would say is like what I've found, I mean, I'm not an educator, but I've talked to lots of educators, is that like it's very difficult for teachers to teach. Like every single one of you teaches what you're an expert in, right? Like you got a PhD or whatever you needed to get to be where you're at. And it's very awkward to teach something that you're not an expert in. So the thing that I would say is that like just fail, go try it, mess up, and you'll figure it out. Like the number one most innovative people that I've worked with, they start with the first day and we're like, we're going to use this stuff. I don't really know what I'm doing. I know you guys don't really know what you're doing, but let's learn together. And you just got to do it. There's never going to be a perfect way. There's never going to be, the stars aren't going to align where it's like, okay, this is how I use it. It's just try and you'll figure out what works for you. But Kamal, I'll pass it to you then.
Yeah, I wish there was a simple answer to this. Nobody has, I think. But uh, learning by doing, like this kind of hackathons, I really love this kind of hackathon. I was part of at least 3 of these in the past. And what we did is, in the past, we used to write papers as one person or a couple of people writing papers. Nowadays, you'll see there's a trend of writing hackathon as a paper. What's the outcome of the hackathon? And I think we should have more of these to have people lock in a room for an hour or so on, give them a task they can solve individually or in a team. And I think this will also build, which is very important for academia, is a team spirit, coordination spirit, and so on, and working for solving a problem. Because you have the exposure to the tool, but can you actually solve this problem in a particular amount of time? That's the question. So, in my opinion, this kind of webinars, hackathons, these are the way to do it. So, I appreciate what you guys are doing. Yeah.
Thank you so much. I do want to open up. We still have 10 minutes. If you have other questions, please feel free to throw them into the chat. I did see one pop up, but I am wondering for our co-sponsors, our co-collaborators, I see Mike has his hand up, but we do have our other co-partners from UBALD, UMBC, and JHU here. If any of our other panelists have any questions, please feel free, but I'll pass it over to Mike.
Yeah, Kamal, this one's for you. So you've given us examples of how agentic AI is informing the work of material scientists. Have you interacted with colleagues in other science disciplines? And can you speak to examples of how AI tools, especially agentic AI, has been changing their work in similar or different ways to what you showed us?
Excellent question. And this is one of the reasons why I'm at Hopkins. It has remarkable biology and other medical fields. So we have been trying to successfully, we have integrated some of those tools from biology, medicine, and so on in the atomview.org. Is going to be available soon. And we are writing massive proposals to fund this for the government and industry to fund this. This requires investment, this is not just taking all the literature data. We have to build domain-specific data set first, then make it API ready, and then make it agentic framework ready. So this requires a lot of work. So we are working with several partners, more than 20 or 30 partners at this time, as of today, and invite, if you are listening to my talk either live or on YouTube, please feel free to reach out if you have ideas. This is the time we work together and solve, especially for science. Yeah.
Thank you.
Sure.
I see John has hopped in. Feel free to ask your question.
Sure. Thanks both of you for joining us today. Really appreciate your insights. I did have a couple questions for Zach. Number one, is there a way to surface the custom instructions inside these bots that you're going to? Can you find out like what they're doing? So is there a call for that? And then number two, is there a product in Boodlebox that's similar to Google Notebook LM that's kind of a grounded model? So
So first question, if you want them, just reach out and I can send you the instructions that they have. But I would
like can anybody else? I mean, so we could send you, but can you ask the bot like will it tell you, or is it instructed not to tell you?
So you can be like, what are you doing? You know what I mean? And it'll tell you about it. Like there's no instructions for it not to. And then second question, what was the second question again? Sorry.
About Google Notebook LM. Is there a feature in Boodlebox?
Yeah. So yes, like there's a RAG system in Boodlebox that you can like ask questions to documents and it'll ground it in the documents, but I will just be completely transparent that it is not the same quality as Notebook LM. Notebook LM is its own monster that is incredible, and I highly recommend everyone using it if you don't use it. It's a great tool. I like to say like Boodlebox and Notebook LM are the two tools, you know what I mean, for teaching and learning and for students. But as soon as Notebook LM gets an API, it'll be in Boodlebox.
Thanks.
Yep.
So I do see one more question. I think this would be a great way to end because both Zach and Dr. Choudhary have experience with bot building and creating and making something that is accessible to different groups of people. So at the core, where do you what are the kind of core things you need to understand for building your own bots, whether that's based on the platform you're using or based on the language model you're using? I'm just curious, what should someone know if they're interested in building their own bot? What should they understand?
I would say that they just need to know about whatever they know about, and be able to articulate that to someone. The thing I tell people, and Kamal chime in on this as well, but like I write all of my custom bot instructions using AI. Like there's a bot builder within Boodlebox that'll help you do that. But I'll just go in Claude on Boodlebox and be like, I want instructions to build a bot that does X, Y, and Z things. Test it out. If it doesn't work, I tell Claude why it's not working and what it's not doing, and it'll fix it. And it's just the thing I'll tell people is it's very iterative, right? You just got to go back and forth, and you just keep your expertise at the center of everything you're doing. One tip I always tell people, get AI to ask you questions. Like, be like, what information do you need to better help me? And it'll ask you a bunch of questions and then answer those, and it'll do good. Like, I liked what Kamal said. Like, I always say AI is the stupidest smart person that's ever existed. Like, if you don't tell it exactly what to do, it's going to go rabbit hole and do something wrong. But I'll pass that off to Kamal.
Yeah, yeah, I have done vibe coding in that way as well. But I think I'm a bit old-fashioned in that respect. I like to do a very simple thing like hello world. Can you do hello world of making a chatbot like Django, fast API? I think these are not really well taught across several disciplines, but there should be. Why don't we make a how to make a simple calculator, add two numbers app for each student as an assignment? From there, we can go how to write a poem and so on. And this will make them curious to learn about it more. Instead of just saying this, here's a tool, just go learn it. I personally believe it should be ground up. So that will be my strategy. Yeah.
Wonderful. Thank you both so much. I'm going to share my screen as we wrap things up. As I mentioned in the chat, but I'll say aloud, we always record these sessions and post them online. Our registrants will always receive an email copy with not only the link to the webinar, but any materials that our speakers want to share and stay connected with you all. So I'll be sure to gather all those things at the end of this session. But I also wanted to share, we have been really grateful to run this series again this semester, and we would love to know your feedback on things that we can take into consideration as we do future iterations of this program. Dr. Stansbury, is there anything you'd like to say before we depart?
Thank you, Julia. Thank you, Zach and Kamal, and all of the collaborators on this series. It has continued to be a pleasure to work with you all, and we are extremely grateful for our audience that continues to join us each month. Again, please take some time to fill out the survey. It's really important for us so that we can make sure that we're meeting your needs. And thank you so much.